So in the last class, we have started bigger method, right? We will do its one or two examples. Then we will end with this topic. So just the introduction at what we have done in big method. This is same as your simplex method, but bigger method we apply when we have constraints either of greater or it is of greater than equal to. So when you have constraint equal or greater than equal to, there you need to add your artificial variables. So when you add your artificial variables in the object, in the constraints, so that it should form your identity matrix. And what you do with that artificial variable, that in the objective function, you take minus m into your artificial variables. If your objective function is of maximization and you plus m times your artificial variable if your objective function is minimization. The rest criteria is same, that you have to choose most negative for the maximum to enter and then you have to decide your leaving variable. So we will discuss one more example. If you have an objective function like maximize z, this is 2x1 plus 3x2 plus 4x3, subject to you have constraints 3x1 plus x2 plus 4x3 less than equal to 600, 2x1 plus 4x2 plus 2x3 greater than equal to 480, and the last constraint 2x1 plus 3x2 plus 3x3, and that you can take 540, and x1, x2, x3 now given to you are greater than equal to 0. So if it is given to you, use or solve it. You know yet you cannot apply your simplex method over here. Why? Because all the inequalities are not of less than type. So you have to convert it into the first standard form. Standard form, the first criteria is satisfied that my all variables are greater than equal to 0. My right hand side is positive. The last task is that I add. Here I need to add slash variable in the first constraint. So I am taking S1. So this will become equal. And if I subtract minus S2, then it will become equal. And again I have to do nothing over here. We are end with this. Now when you start with this, so what I have told you that you should make your identity matrix. इसका मतलब जहां पे भी आपका इक्वल टू कंस्ट्रेंट है या ग्रेटर देन है, you have to add your artificial variable in that. So there you have surplus variable. So here you will add one your artificial variable. Since I am adding it in the second constraint, so I am giving the name 8. You can give any name, right? Here this is your third constraint. So I have to add the third artificial variable. So there was a equality constraint. You have not added any slack or surplus variable. That means there is need to add your artificial variable. So when you form your A matrix, what will be your A matrix? That is the column of x1, column of x2, x3, s1, s2, a2 and a3. So this will be your 3, 2, 2, 1, 4, 3, 4, 2, 3. This is 1, 0, 0, 0, minus 1, 0. A2 is 0, 1, 0 and A3 is 0, 0, 1. Your right hand side B is 600, 480 and 540. And your C matrix, the cost coefficient, that is your 2, 3 and 4. So when we do the iteration, so what we do for the first iteration, So here I can write my Zj minus Cj. And this is the column of x1, x2, x3, s2, S1, S2, and this is your A2 and A3. So this is your XB. And what you write, firstly, what will be your basic variables, which are forming your identity matrix. So it is forming S1 is making the identity matrix. So here it will be S1. From the second constraint, what will be A2. And from the third constraint, it will be your A3. The cost coefficient when you do it in the standard form, now it will be plus 0 into S1, plus 0 into S2, plus 0 into S3. Now, the objective function is of maximization. So I have to do minus M times A2 minus M times A3, right? So this will be my 0, minus M and minus M. फॉर द फर्स्ट आइट्रेशन हम क्या करते हैं, पूरी की पूरी ये मैट्रिक्स लिख देते हैं. सो दिस इज माय 3 2 2 1 4 3. दिस इज 4 2 3. दिस इज 1 0 0. दिस इज 0 minus 1 0. And this is 0 1 0 and 0 0 1. And here will be my right hand side 600, 480 and my 540. Is it clear? So what you do for Zj minus Cj, I have told you, you can revert the sign and you can write over here. This is minus 2, minus 3, minus 4, 0, 0. And if you change the sign, it will become M and M. Is it clear? Now when you have Zj minus Cj corresponding to your basic variable, Zj minus Cj should be 0. But here it is not 0, corresponding to your A2 and A3. So what you have to do, you have to make this element as 0. So that I have told you that either you can calculate your Zj minus Cj with the formula that Cb into alpha j minus Cj, or you can use your row operations that will also convert your Zj minus Cj into 0. So if you will use formula, if you calculate Z1 minus C1, so it will be nothing. The cost coefficient of S1 is 0. Cost coefficient of A2 is minus M. Minus M. Alpha J is my 3, 2, 2. And the cost coefficient of X1, this is my 2. So when you will multiply, it will be minus 3M, minus 2M, minus 2M, minus 4M, minus 2. Right? Or you can apply your row transformation, that now you can apply your transformation to R naught. You can apply the joint operation. यहाँ पे आपको M को 0 बनाना है और इस M को भी क्या बनाना है, 0, but with the help of this one. So what operation you will apply? You can do R naught minus M times R1 minus M times R2 and minus M times R3. So if you will apply this operation, this will give you minus 2 minus 4M that you have already got from this. So either you can use the formula or you can use your row operation to convert. So this will become minus 3 minus 7M. This will be minus 4 minus 5M, 0. And this is your M. This will become 0, 0. And it will become minus 1020M. Is it clear? Yes or no? So now this is my maximization case. जिनको M में problem आ रही है, that you are confusing with M, you can give very large value to your M. जैसे यहाँ पे आपके 600, 480 और 540 already हैं. You can give M as 10,000, M as 1,000 as per your given statement, right? It will not affect your question. तब आपकी की actually calculation, you can say it will become easy. So you can give any value to M, and M is very large value. You can give 1,000 for the calculation. You can give 10,000 for the calculation, right? So you can do. Now the task remains same. I can stop only when my all Zj minus Cj will be greater than equal to 0 for the maximization case. Now this is my maximization case. If my m is very large, suppose m is 1000, क्या मेरे सारे Zj minus Cj पॉजिटिव हैं या नॉन नेगेटिव हो या जीरो हो? No, your all Zj minus Cj are not greater than equal to 0, so you cannot stop the iteration. So how, if you cannot stop the iteration, that means there is one entering variable. So how you will decide your entering variable? That is your most negative entry in your this Zj minus Cj. If you give m as 1000, it will be minus 4002. If you give m as 1000, it will be minus 7003. If you give m as 1000, it will be minus 5004. And this is 1000. So which is most negative? So that means your x2 is your entering variable. So if x2 is entering variable, you have to decide your minimum ratio. Minimum ratio is nothing but xb divided it by your entering column, or you can say alpha j, and alpha j should be greater than 0. So I can divide 600 by 1. That will be my 600. I can divide 480 by 4. That will be 120. And I can divide 540 by 3. So that will be my 180. So which is minimum? 120. That means this is my leaving variable. What will be my pivot element? The intersection of entering and leaving variable. This is my pivot element. So if this is pivot element, what we have to do with the pivot element? We have to make it 1. We have to make this as 0. We have to make this 0. And we have to make this element as 0. So you can apply your row transformations. So here will be my Zj minus Cj. And on the place of A2, S will remain in place. A2 की जगह मेरा क्या आ जाएगा? X2. A3 will be on its place. The coefficient of S1 is 0. X2 का coefficient objective function में क्या है? That is your 3. A3 का coefficient क्या है? Minus m. You have to make this element as 1. So how you will make this element as 1? So you will apply the operation R2 divide by 4. So it will be my 2 by 4. That will be 1 by 2. This will be 1. 1 by 2. 0 minus 1 by 4. 1 by 4. 0. 120. I have told you, if any artificial variable leaves you, either you write its entry in the next or not, it does not affect. So once it will leave, you will not let it enter in the basis again, right? So you can even skip these entries. So here you have to make this 0. What operation you will apply on R1? R1 will be R1 minus 1 into your new R2, right? So this will become my 5 by 2. This will be 0. 7 by 2. 1. This will become 1 by 4. And this is my 0. This is my 480. Again, I have to make this element as 0. So what operation I will apply? R3 minus 3 times my new R1. R2, sorry. New R2, right? So this will become 1 by 2, 0, 3 by 2, 0, 3 by 4. This entry I am not writing, 1 and 180, right? So next you have to make this element as 0. कैसे बनाओगे 0? You will apply operation on R0. R0 will be, किससे मल्टीप्लाई करोगे इसको? 1 को किससे मल्टीप्लाई करना है? 3 plus 7m से, या -3 minus 7m से, that you can divide. So R0 plus, if I am writing 3 plus 7m into your new R2. If you have confusion with m, You can do your calculation by taking m as very large value, but वो वाली value लेना जो आपके coefficients पे कहीं पे भी नहीं आ रही, right? So that you should not confuse. So this zj minus cj, if you will apply the operation, it will become minus half minus m by 2, 0, minus 5 by 2 minus 3m by 2, and this will become 0. This will become minus 3 by 4 minus 3m by 4. This I am not writing, and this is 0, and this entry will become 360 minus 180m. Is it clear? Now, your objective is maximization. You can stop only when your all zj minus cj are positive or non-negative, right? So now if you are taking m value as very large value, m अगर आप 1000 लोगे तो कौन सी value है? This is 1000 divided by 2. This is, now you have, all these are negative. They all will give you negative value. So you have to choose most negative. So if you will choose most negative, this will give you most negative. That means this is my entering variable. So if this is my entering variable, I have to decide the leaving variable. So my leaving variable will be 480 divided by 7 by 2. 120 divided by 1 by 2. This is giving me answer as 960 by 7. This is giving me answer as 240. And this is giving me answer 180 divided by 3 by 2. So that will give me answer as 120. Which is minimum? That is your 120 is minimum. So this will leave the basis. That means which is my pivot element? 3 by 2. You have to make this element as 1, this element 0, this element 0, and this element as 0. So when you will perform your iterations, so now this is my pivot element. That means S1 will be on its place. X2 will not change place. On A3, what will come? My X3 will come. And the cost coefficient of S1 is 0. X2 का coefficient क्या है? 3. X3 का coefficient क्या है? 4. Right? So now you have to do the entries. You have to make this element as 1. So which operation you will apply? R3 into your 2 by 3. So when you will apply this operation, this will become 1 by 3. This is 0, 1, 0. And this will become your 1 by 2. This entry you can leave because once your artificial variable leave the place, you need not to calculate its entries, right? And this entry will become your 120. The operation here you will apply. You have to make this element as 0 with this help 1. So you can apply the operation on R2. That will be R2 minus half into your new R3. So when you will apply the operation, it will become 1 by 3, 1, 0, 0, minus half. And these entries we are not calculating. This is 60. Now you have to make this element as 0. So we will apply the operation R1 minus 7 by 2 times new R3. So this will become 4 by 3, 0, 0, 1 minus 3 by 2. And this will become my 60. And this Zj minus Cj. This entry again you have to make 0. So what operation you can apply on R0? R0 will be plus 5 by 2 plus 3m by 2 into your new R3. So that will become your 1 by 3. This will become 0, 0, 0 minus half. This we will not calculate. And this value is coming as 660. So now all your Zj minus Cj It is, I think, positive. Half. So now your all Zj minus Cj are greater than equal to 0. That means you can stop at this iteration. So what is your optimal answer? That is x1 is my 0 because it is not present. X2 is nothing but x2 is this value 60. X3 is my 120. This is my optimal solution. And the optimal value is Z, that is equal to 660. That even you can verify if you will multiply 0 with 60 plus 3 with 60 plus 4 with 120, you will get this entry as 660. This is the dot product of CB and XB. So the next example, we will do the simplest case, that minimize minus 3x1 minus 2x2 subject to you have constraints 2x1 plus x2 less than equal to 2, 3x1 plus 4x2 greater than equal to 12, x1 and x2 all are greater than equal to 0, right? So when you have to apply your simplex method, simplex में नहीं भी बोलूं, when you cannot apply simplex because here the inequality is greater. Simplex you can apply only if you have to add slack variable in every constraint, right? So when you will convert it into the standard form, it will be my minimize z minus 3x1 minus 2x2 subject to you have constraint 2x1 plus x2. S1 you are adding in the first 3x1 plus 4x2. You will subtract your surplus variable. I am adding artificial variable in the second constraint. I am giving name as A2. So your x1, x2, s1, s2, a2 all are greater than equal to 0. Because this is minimization case, so here it will be 0 into s1, 0 into s2 plus m times a2. I have given the name A2. This is your choice. You can give any name. So when you will start its iteration, artificial variable you always add to make the identity matrix, right? But here is the main role. If you have objective function, you are adding plus m into A2. But if you have no objective function as maximization, then you will do minus m into artificial variable, right? So here you will start with the solution. What will be your basic variable and CB? Now from the first constraint, I have added slack variable. Slack variable will always come in your basis. In the first table. In the second, you have taken A2. In some of the books, they don't write CB. That is your wish. Either you want to write or not, because it does not have any significance. Just I add you so that you can multiply your CB with the XB. So you can dot product. So that is your wish that you want to add it or not, right? So S1 coefficient is 0 and A2 coefficient is M, right? Here I am writing X1, X2, S1, S2 and A2. This is my XB. So when I have to write the first table, I will just enter. This will be my 2, 3. So this is 2, 3, 1, 4. S1 is present in first, not in second. 0, -1 and this is your 0, 1. Here it will be 2, 12. And when you write your Zj minus Cj, just revert the sign. It will be 3, it will be 2, it will be 0, 0 and minus m. Now when you write Zj minus Cj, आपका Zj minus Cj basic variable के लिए क्या होना चाहिए? 0. So either you can apply your row operation or you can use the formula. So if you are using row operation, so that will be R naught plus M times your R2. जिससे आपको 1 की हेल्प से 1 M बनाना है. So this entry will come 3 plus 3M. M you can also take very large value. This will be 2 plus 4M. And this will be 0. This will be minus M. This is 0. Obviously, it is here 0, 12 into M. Even you can multiply 0 into 2 plus M into 12. So it will give you 12M answer. Now, this is your minimization case, right? So if this is minimization, you can stop your iteration only when your Zj minus Cj all are less than equal to 0, right? If it is less than equal to 0, if you give large value, so that means you cannot stop over here. So this will be your entering variable because this is 4002 and it is 3002 if I am giving M as 1000. So this is entering. Next task is to find your minimum ratio that you divide 2 with M and 12 by so this is now this is my entering variable. I have to decide 2 divided by 1. It will give me 2. 12 divided it by 4. It is 3. Which is minimum? 2. That means this is my leaving variable. So this is my pivot element. This is already 1. So you need not to write the row transformation. Just what you can change the basic variable. So here entry will be your Zj minus Cj. S1 की जगह पे आपका क्या आ जाएगा? X2. A2 will be on its place, right? X2 का coefficient क्या है? -2. A2 का coefficient is M, right? Now, you need not to perform any iteration. This will be 2, 1, 1, 0, 0 and this will remain 2 because it is already 1. So you have to make this element 0, this element as 0. So you can apply your row transformation. R2 will be R2 minus 4 times your new R1. So when you will apply this operation, this will be -5, 0, -4, -1, 1. This will be 4. And you have to make this also as 0. So this, you have to make element as 0. So you will apply your row transformation R0 minus 2 plus 4 times M into your new R1. Is it clear? So when you will apply, this will become your -1 minus 5M, 0, -2 minus 4M, minus M, 0. This is -4 plus 4M. So this is your minimization case. You can stop when all your Zj minus Cj are less than equal to 0. If you give M as 1000, तो क्या सारे Zj minus Cj are less than equal to 0 है? Yes. That means this is your optimal iteration. You cannot perform it further, right? This is the key point over here. So in the last optimal table, your artificial variable is still present in the table. So if artificial variable is present in the last optimal table, then LPP has infeasible solution. करे थे ना हमने cases कि infeasible कब होगा? That means ये solution मेरा infeasible solution है. क्यों? क्योंकि A2 आपने अपनी मर्जी से लिया था. but that you have to give so much penalty to include that variable. That means अगर आप A2 enter कर रहे हो, आपको जो है मतलब M आपने पॉजिटिव लिया 1000 ले लिया और A2 की वैल्यू आपकी 4 आई है, तो इसका मतलब आपको 4000 रुपीज पे करने पड़ रहे हैं, जो आप नहीं चाहते. So whenever your artificial variable is present in the last optimal table, then LPP has infeasible solution. LPP has infeasible solution because artificial variable is present in the last optimal table. So we will discuss all the cases: infeasible, LPP unbounded, LPP infeasible. That means in this case you have infeasible solution. LPP alternate optimal. We will discuss all those cases in simplex also. So when you will apply your simplex method, अगर आप सिर्फ सिंप्लेक्स मेथड लगा रहे हो, यू विल नेवर गेट योर इनफिजिबल सोल्यूशन, क्योंकि वहां पे आप अपने आर्टिफिशियल वेरिएबल इंट्रोड्यूस ही नहीं कर रहे हो. यू विल नेवर गेट योर आर्टिफिशियल वेरिएबल. इवन अगर आप इनमें से x2 और a2 को अपने कंस्ट्रेंट्स में सब्स्टिट्यूट करके देखोगे, योर वन ऑफ द कंस्ट्रेंट विल नॉट सेटिस्फाई. दैट्स व्हाई इट इज इनफिजिबल. इनफिजिबल यही बोलते थे ना कि अगर आपका कंस्ट्रेंट सेटिस्फाई नहीं होता, you say that is infeasible. So if you will put x2 is equal to 2, a2 is equal to 4, x1 as 0, your one of the constraint will not be satisfied. Is it clear? And yes, the one more key point: if artificial variable is present and it is at 0 level, अगर आपका आर्टिफिशियल वेरिएबल प्रेजेंट है 0 लेवल पे, मींस मेरी ये वाली एंट्री 4 नहीं होके अगर मेरी ये एंट्री 0 होती, तब मेरा ऑप्टिमल सोल्यूशन होता, राइट? सो इफ आर्टिफिशियल वेरिएबल इज प्रेजेंट and you can say and it is not equal to 0, then you have infeasible solution. But if artificial variable is present and it is 0 level, that means that is your a2, अगर आपका यहाँ पे 0 आता, then you have optimal solution. In that case you should have optimal solution, और आपका optimal solution वही होता, you didn't get x1, so आपका x1 0 हो जाता और x2 क्या हो जाता, 2. Is it clear? So in that case you can have solution. तो यहीं पे नहीं छोड़ देना. Tips and tricks: that artificial is present and it is 0. Options are LPP infeasible, has an optimal solution, unbounded and all that. So there you have optimal solution because artificial is variable is present at 0 level, right? So it is not affecting your actually LPP. So when you will put in the constraint, it will satisfy your constraint. But if you put these variable in two of the constraint, your any one of the constraint will not satisfied with this inequality. Is it clear? So next, the last method we will start. Just I am giving you the introduction. Two-phase method. Two-phase method basically the same. It is also used when you have equality as equal or greater than, means जहां पे आपको अपने artificial variables introduce करने पड़ रहे हैं. Like what is the benefit of two-phase? As its name is indicating two-phase, means we will solve the problem in two phases. Solve problem in two phases, that is phase 1 and phase 2. What is the benefit of this method? Like you have done bigger method, तो हो सकता है आपने 10 आइट्रेशंस करी एंड आफ्टर 10 आइट्रेशंस यू गॉट टू नो दैट आंसर इज वाज इनफिजिबल, right? So it can happen. So what happens with two phase, that when you have two phase method, from the phase 1 you will decide कि आपका optimal solution exist करेगा या नहीं. If optimal solution will exist, then you will go to your phase 2, otherwise आप वहीं पे ही छोड़ दोगे and you will say it does not have optimal solution, right? So here we make two objective function. In the phase 1 we take only artificial variables as in the objective function, and in phase 2 we do iteration, and if it's optimal, that means अगर उसका optimal solution exist करेगा, then we will move towards this iteration. So when you will move to phase 2, अगर आपका artificial variable last के table में present नहीं होगा, and if it is present it should be non-zero, sorry, it should not be present, and if it is present it should be equal to 0. Only then you can start your second phase. So in this you take auxiliary objective function. Auxiliary means आपके पास कोई भी ऑब्जेक्टिव फंक्शन है, अगर मैक्सिमाइजेशन है तो जैसे आप करते थे कि आप माइनस एम इंटू आर्टिफिशियल वेरिएबल करते थे, हेयर यू गिव एम एज योर वन वैल्यू, that is -1 into your artificial variables. That will be your objective function for maximization case, and it is 1 into your artificial variables. So some of the books write that in the phase 1 there is only the one objective function, that is minimization. वो इसीलिए लिखते हैं क्योंकि माइनस ऑफ आर्टिफिशियल वेरिएबल करो, अगर मैं माइनस साइन कॉमन ले लूं, इट विल कन्वर्ट द प्रॉब्लम इनटू माय मिनिमाइजेशन, राइट? ऐसे ही करते हो. अगर मुझे मैक्सिमम निकालना है -1 -2 -5 का, दिस इज सेम एज कि मैं मिनिमम निकाल दूं 1 to 5 का. सो दैट मीन्स इफ यू निगेट द साइन you will find the minimum, and if you will multiply it with minus you are finding the maximum. So some of the books write there is only one objective function, that is minimization, that you take 1 into the artificial variable. Okay, we will start with this in next class. Thank you.